Okay, I'm Ed McLean, and I'm going to talk about fibers today. Just a little bit about my background. I actually hail from the state of Illinois, the state of corruption. And I grew up in a limestone quarry family business. We sold the quarry business about 3 years after I got out of college, and I ended up in the concrete pumping business as well as ready mix. I had 5 ready mix plants that I had the controlling stock and interest in. And having the knowledge of aggregates, I knew how to make good concrete. I think anybody in here who's in ready mix can attest to that. Who's all from ready mix in here? Let me get my phone. I'm calling you guys in for crack dealers, okay? Because that's what we're going to talk about today, a little bit of cracking. That was the thing that happened. Is I no sooner take ownership of this ready mix company, I get phone calls. Your concrete cracks. Your concrete cracks. My concrete wasn't cracking necessarily. It was how much water was going in that concrete. And lo and behold, this lady comes in one day. Her name is Jan Wainstreet. She was with Fiber Mesh. Now this is back now in 1985. And she says, I bet you're hearing a lot about cracking. I said, yeah. And she says, I got just the solution for you. I have actually been utilizing the use of microfibers since 1985. And we're going to talk a little bit about that and other technologies and fibers and why everybody is here. And back to my background, after I sold out of that business, I went to work for Lone Star Cement Company. And from there, I actually championed and invented a number of cement solutions, including pyramid cement. I was with CTS Cement and helped make up a different couple of the calcium sulfur aluminum cements. But I also was in the fiber side of things, and one of the things I did was I helped launch the Buckeye Fiber, which is the Ultra Fiber 500, back in '99 and 2000. It was a fiber that had been being used by the most fiber being sold in the whole world was a cellulose fiber, and the biggest user of it in the United States was Hardy Board. So anybody buys Hardy Board products, it's all got cellulose fiber in it. Has been for years. So it was pretty simple to understand the technology. How do we get ready mix people to use it? That was the key, okay? And so that's kind of a little bit about my background. I was here for about 3 years, director of fiber products, got the product back up online. Get back because it's a great fiber. It does a real good job in the microfiber family. So that's a little bit about my background. I'm an engineer by education, civil engineer, but I'm probably more of a materials person. Guys, try to find a couple of seats here, yeah. So I want to start out here by talking about good concrete. And the ready mix guys will tell you the same thing. And that is that it's really up to the contractor to order the concrete that they want and intend to have on the job site. If he calls up and says, I want a 4,000 PSI concrete with air entrainment, I probably got about a dozen different mixes that I could utilize to meet that. But if I now know that I want a 4,000 PSI concrete with air entrainment and I'm going to be doing a finished floor or a patio, I'm going to know not to send you a product that's got, let's say, lignite in the sand. And a good example, in St. Louis, Missouri, we have some really good limestone, but we have Mississippi River sand, and then we have Merrimack sand. The Merrimack sand does not have any lignite in it. The Mississippi River sand's got a bunch of it. So if I'm going to do my driveway, I don't want pop-outs because that lignite takes on water over the wintertime and grows or expands and plops out. I don't want pop-outs. So as a contractor, I need to order the right concrete. And I'll tell you what, there's not a ready mix producer in this country today that can't make good concrete, or what you want to have as good concrete. What fibers do is make good concrete better. Fibers don't make bad concrete better, they make good concrete better. So fibers are not intended to be a fix to a bad concrete. Fibers are intended to be an additive to the concrete to make it better. That's a little simple rule that I like to get off to on the start. Now, this is unacceptable on any job, all these cracks, correct? We don't want to see these cracks. Ready mix guys don't want to see these cracks, so you're going to get a phone call, right? Okay. You guys in the field don't want to see these cracks. And so there's a lot of things we need to make sure that we don't get these. One of them is we want to make sure that we do a good job of compacting the sub-base if it's a slab on grade. You got to do that. You put some rock down so you have that medium, that base material underneath the concrete. And then we go to place this concrete. We want to place a concrete that is workable, but yet not too much user water in there. We want to make sure that water convenience, okay? We got to have enough to make it workable, but we can't get too much in there because we know we're going to lose that. We're going to lose that from evaporation. That loss of water is loss of value, and we're going to end up with something like that. We would much rather deal with concrete that looks like this in the end. Come on in, guys. I don't know if you want to get them around over there so they can see the screen. This concrete right here is just plain good old gray concrete. We don't want to see cracks in that. We put joints in there. We want it to crack in the joints. We want to go activating the joints. Up here we got some decorative concrete. We sure don't want any cracks in that either. So our intention here is to try to come up with the best looking concrete, because the other one was not too acceptable. And I'm sure that you know which one is important to you, what you're looking for. So what are we doing as contractors? We're trying to do things on a daily basis. We want to have a very nice product when we're done, but we want to save money getting there. So if you think about it, if you don't use good concrete, or if you do some bad practice, it's going to cost you money. So start out by, we're going to want to save money, we want to save time. We want a concrete that's going to be very consistent, so that we know that our crew can put this type of concrete down this much in a certain time period, and we can be off at the end of the day, not waiting, not having extra costs involved. Labor costs, like I was just talking about. Prevent callbacks, birth defects. We want all these things, right? So it's a combination of working things together, being smart, using good concrete practice, and we'll end up with good product like we just saw in those pictures a little bit ago. A little bit of basics for the non-ready mix guys. We have three kinds of concrete in generality. We have a typical concrete mix, which is rock and sand, water and cement. And the rock and sand is usually a 55-45, 55% rock, 45% sand. Now, if you go to Omaha, Nebraska, Lincoln, Nebraska, they don't have a lot of rock resources up there. So theirs is going to be more like the topping mix, where it's actually small rock, sand, cement, and water. And sometimes the amount of rock, the actual rock, may only be about 30%. Then we have the grout mixes, which are sand, cement, and water. Okay? In some parts of the country, they'll place this and then come back with a grout mix, they call it a topping mix, as their finished topping. They actually do a two-step method. You go up to like Seattle, you get up into the Canada area up there. They do a lot of combinations, and it's kind of interesting how they do that work. But everybody does things a little bit differently, okay? But in the most part, for the country, the top is what we use for a concrete mix. This is what we're going to use for all of our decorative concrete needs, except for overlays. Cubic yard of concrete, 4,000 pounds. That's an average. 3,800, 3,850, 4,000. Here's the key factor. 3,100 to 3,200 pounds of that concrete is the rock and the sand. So how important is rock and sand in that concrete of 4,000 pounds? It's critical. Going back to what I said about the sand and the rock in the beginning here, this is a critical component right here, the rock and the sand. So you want to, the ready mix guys will tell you right off bat, that's where our strength is. It's in how we hold that together with the glue, which is the paste, which is the cement and water. They yield out at 27 cubic feet. Now, with the computers today and everything else, I don't know of any ready mix producer in this country that's trying to under yield or over yield. They want to hit 27 cubic feet. So if they have a mix design and it yields a 5-inch slump concrete, okay, this is for example, a 5-inch slump concrete, that water cement ratio, the amount of water they're using in there, let's just say it's 32 gallons per yard. Just going to use that number, it's a pretty close number. If they go in and they put 33 gallons of water in their yard, you're going to get more than 27 cubic feet, aren't you? Okay? If they use less than that, you'll be lower than that. But if they hit that pretty close, at 32.5 to 33.5, they're going to be right in there, okay? And the amount of that of extra available water of convenience for finishing and everything, it can be controlled with, because we know that we're dealing with this concrete, and we can control that to a certain degree. Let's go to Denver, Colorado, where it's dry and windy. That water, that water of convenience, it's going to get sucked out of that concrete like you wouldn't believe. And I don't care if you're doing a slab on grade or you're doing a structural slab, you want to put some fibers in there, because guess what fibers, those microfibers do? They act like little bridges, and they keep the water from leaving the concrete, which is a neat thing because you want that water to hydrate, and you don't want that volume loss, okay? So there's reasons for using certain fibers for certain applications there. That loss of volume, you're not losing volume from the rock and the sand. The rock and the sand may absorb a little moisture, but that you're not losing water there. That water's staying in there. And in fact, if it does take on some water, when the cement hydrates, it'll pull some of that water out of those aggregates, okay? But that extra water, though, that's in that mix that's in there, that's coming out, that water of convenience, it's going to lose, you're going to lose volume, and it's going to relate to cracks, period. We found a long time ago that these little fibers, the microfibers, do a real good job of controlling that. Those little cracks that happen in the first 24 to 36 hours, we call those plastic shrinkage cracks. That's a kind of a term that we've coined for that period of time. After that period of time, you start getting shrinkage cracks, okay? They can start as plastic shrinkage cracks, but they can become actual shrinkage cracks depending on how much water's in there. And I'm going to give you a good example. If I were to build a warehouse building right now, let's just say this was the room, I place this concrete, and tomorrow I turn the air conditioning on, okay? Air conditioners do something they call dehumidification. I'm going to suck the water right out of this concrete, and I'll guarantee you I'll probably get a crack right down the middle of this floor, okay? So we have to be observant of what we're doing, not just the environment that we have on the outside, but what can happen on the inside. What happens in a lot of big warehouses, and I've seen this happen like in beer distributing warehouses and food distributing warehouses, they'll place a concrete, they'll have to do everything right. They 6 inches, 8 inches thick, 20-foot joint spacing, everything is perfect in this thing. And a month later, or maybe 8 weeks later, they'll turn that air conditioning on, and suddenly those joints, they go like this. They go whoop. And you know what they'll have done before they did that? They will have put MM80, which is a brittle joint sealant, down those joints. That concrete shrinks, and now there's this gap now in that joint sealant. Anybody see that ever before happen? Okay. It's a typical thing that happens with concrete. So shrinkage is an interesting thing. If we use the fibers correctly, now microfibers, this isn't macrofibers, steel fibers, carbon fibers, this is just microfibers, fibers like your hair. If we use those effectively, we can reduce that issue from happening, okay? We can't eliminate it, but we can sure give ourselves a fighting chance. Kind of like putting the suspenders on when you've lost some weight and the pants don't fit real good, okay? So, and they're slipping down your side there. Okay, another thing, we can optimize the mix. If I take the standard materials in St. Louis, Missouri, I know that if I make a 4,000 psi concrete, I'm going to have about 5/8 of an inch shrinkage in 100 feet. That's basically a 0.58 shrinkage factor, okay? I can tell it to you in micro strains and everything else. This is very technical in some cases, how we measure. But basically, you're losing 0.5% of your in shrinkage. If I go to Kansas City and I use their indigent materials, I'm going to be up about 0.7. So I'm going to, instead of being 5/8 of an inch in 100 feet, I'm going to be more like almost an inch. It's almost close to an inch. So you got to know what kind of shrinkage you have in a marketplace. So if you leave one market, where are you from, sir? Where are you from? Yeah. Columbus, Ohio. If you go from Columbus to Cleveland, there's a difference in the shrinkage in the materials there. Okay? I guarantee it. I know it. Just know it real well. And so you need to know that when you go there so you can be comfortable with how you deal with your joint spacing and how you cure your concrete. When you throw fibers in there, you give yourself a little bit of a fighting chance already. Okay? And I'll be honest with you, you'll probably find out they use more fiber in Cleveland than they do in Columbus because of that very thing. There's other things you can do. You can use fly ash, silica fume. One of the other things is if you're doing thicker floors, like the 7, 8, 9 inch thick floors, you can use 1.5-inch rock. That helps out. So you use a 3 rock, you use your normal concrete stone, you use the larger stone. That helps reduce that shrinkage. There's a lot of things. The other one is reduce your water cement ratio. Now, if I got a laser screed, I can put down 4-inch concrete all day long. If I've got a hand strike off or a vibra strike, I'll tell you what, I'm just like the rest of the laborers and the finishers out there. I don't want to strike that off. No way. I want some more workability. But guess what? Sometimes we got to do what we got to do. That's where maybe some admixtures such as high-range water reducers come into play. Some of the mid-range water reducers work real well also. Okay, so how do we determine the proper joint spacing? This is another critical thing that we need to talk about. When ACI put this together was something like 35 years ago. This is right out of ACI 360, which is design of slabs. They basically said, let's say we have a normal shrinkage concrete, a high shrinkage concrete, and a low shrinkage concrete. And if you can see this up here, let's just say I have a 4-inch thick concrete, okay? And my joint spacing for a typical normal shrinkage concrete is going to be 10 to 12 feet, right? But now let's say I put a whole bunch of water in that concrete. It becomes a high shrinkage concrete. Now I can only go 8 feet. So you see what water can do to you. You actually are making that concrete more susceptible to shrinkage. On the other hand, if you go to Cleveland, you're already starting with a concrete that's a little higher shrinkage just because of the materials that you're utilizing. So this is a standard item here. That's where if you hear somebody say 2.5 times the thickness in feet or 2 times the thickness in feet or whatever the way you figure out your joint spacing, if it's 4-inch thick concrete, 8 to 10 foot, 5-inch, 10 to 12 feet, those are your numbers you want to stay with, okay? Fibers are not going to help you extending the joint spacing of concretes that are less than 6 inches in thickness. It's proven. Now, if I've got a big warehouse and I got an 8-inch thick slab, I can put in probably 45 pounds of steel fiber, maybe 6 to 8 pounds of a macro fiber, and now I can look at extending the joint spacing. So I got, let's say, an 8-inch thick concrete here, or let's say 6-inch. Got typical strength concrete. It says I can go up to 15 feet, basically. I could probably push it out to 20 feet. I might be able to get to the joints, the columns in that building, okay? There are things we can do, but it takes a coordination effort of using the right materials, the right fiber, the higher dosages of fiber. So when you get to that 6 inches and greater in thickness, you can start looking at using the fibers to help do some other things. When it's less than 6 inches, you just don't have enough mass. You think about this thickness of this slab right here. There's not enough mass there for putting enough fibers in there to help you with the joint spacing. So try to live with this ACI recommendation as best you can in regards to, whoops, went too far. I'll go back there. So does everybody kind of understand where I'm going with this? Most of you guys are in your decorative concrete are probably at 4 to 6 inches, 4 or 5 inches in thickness. So look at your joint spacing. Realize fibers can help you, but you're not going to be able to increase those joint spacing out. This poor guy here is a new guy in the business. He's going to have a sore back. It's kind of hard having the heavy concrete in front of him and him standing on there to raise the wire mesh. Wire mesh, this is a topic that's come up 4 times since I've been here since 9:30 this morning. What does wire mesh do? The truth of the matter is that wire mesh and rebar have no function in the concrete until the concrete cracks. Isn't that weird? Here's a good one too. 4,000 psi concrete might have a flexural strength of 650 psi. So a 4,000 psi has a flexural strength of 650. Putting wire mesh or rebar in that concrete is not going to change that. That modulus of rupture is the same no matter what. But what happens is when that concrete breaks, if there's some steel in there like that, continuous steel, it's going to do something for you. Wire mesh is just going to hold the crack together. There's not enough steel in there to give you any load carrying capacity. There's not one engineer in this country can show you that. Even the Welded Wire Institute has no calculations for wire to add any type of tensile capacity. Now, if you put some rebar in there, depending on how much rebar, now you can start getting that, okay? But still, the concrete has to crack for one of those to start working. Guess what? Fibers do. Concrete doesn't have to crack to start getting the benefits. That's kind of neat about fibers. Because you get abrasion resistance, you get freestall resistance, or improved freestall resistance, and then also you get some additional average residual strength, meaning that that concrete's going to flex more before it actually cracks. We haven't changed the strength of the concrete. We don't do that. But we're getting a little more tensile capacity. But once the concrete cracks, guess what it does? It tends to hold the concrete together, just like the wire mesh would do. Okay? The reason why we can't say fibers are structural, even though there are some fiber companies out there that like to do that, is because they're discontinuous. There's no way once that crack happens that we can take that load at that crack and distribute it out that way. If it had steel rebar in it, you could. Not wire mesh, but steel rebar, it could take that. But the fibers can't be structural. There's just no way they can be structural. And I just cringe when people say that. And ACI is at ACI meetings we cringe when we hear that type of talk. So here's welded wire fabric, and here's a fiber section here. This concrete had no protection in plastic shrinkage. This one had plastic shrinkage protection. There's an actual test for it. Only a few labs in the country do it. And it's basically a concrete that's placed in this device here that's got some ribs. It gives it restraint, also gives it a place to crack. We want it to crack because we want to measure what that fiber does that does different in concrete that's not reinforced with fiber versus that is. And we look at that crack that's in the middle, how far it goes apart. So it's a restraint test, if anything. There's an actual way, so that we have an actual way to do it. The other thing you can look at in concrete with fiber in it, you can try to break it. And I bet you everybody in this room is trying to break some concrete with fiber in it, right? Isn't it fun? Because you're trying to pull it apart, okay? I got a great story. It was out at the old Denver Stapleton Airport. They had already moved out to the new one. I'm out there with a salesman, and get a phone call. And they said, hey, can you come out here? We're having problems breaking up this concrete. Well, we get out there, and they have a 110-foot boom on a Manitowoc, or 110-ton Manitowoc crawler crane, 100-foot boom on it, and they have this big piece of concrete, size of a car. And the guy's dropping it and letting free fall on the concrete. Well, everywhere he was doing that on the rebar reinforced concrete, 2 or 3 hits, the concrete would break away from the rebar. He turns over this other section behind him, hits that concrete and bounces up in the air. That big piece of concrete does. Just bounces off of there. It turns out that was 20-inch thick concrete with steel fiber reinforcement. Okay? Had like 100 pounds per cubic yard. It had that much resistance. Okay? They ended up having to cut those slabs out and pick them up and put them on trucks and take them away. They couldn't break that concrete up. So that's fiber. Fiber actually holds things together, as you kind of can see here in this picture. There were some beams that were made by the University of Nebraska in Omaha a number of years ago. They loaded them up with steel fiber, and they put them in big beam breakers. And these beams were as long as this table is. And none of them would break. They would just keep bending. You could see the cracks and everything. They just kept bending, and they couldn't get them to pull apart. There was so much steel fiber in there. Okay? So kind of give you an idea how much capacity they could actually have. It still wasn't a structural element, but that's kind of give you an idea what it looks like when you put that much steel in there. Oops. I shouldn't do that. Sorry about that, guys. Okay, so have fibers been around for a little bit? Yeah. We've been using natural fibers in brick, adobe brick, and other concrete structures throughout time. Okay? So that's where we started, was with the natural fibers. In fact, there in Rome, there's a bunch of different aqueducts in this Colosseum thing where they started using volcanic ash, pozzolanic material, which is cementitious, and they would take horsehair and other types of natural fibers, and those structures are still standing today. And when you go to try to hit on them, you can't break them, and they're basically hold together. If you go over to Normandy and look at some of the bunkers that the Germans made up on the bluffs there, they used steel fiber in those. And when the Allies were firing at them, all they could do is put holes in them. In fact, I did some tests with the military down at Fort Leonard Wood, where we made silhouette of concrete of tanks. And we would take concrete that was rebar reinforced, and then concrete that was rebar reinforced with steel fiber, and then some with microfiber. And all with the fiber in there, the added fiber, all we do is put holes through them. When they didn't, just the rebar, it would basically blow up sections. Concrete would fly and everything. So that technology there we use in the military all the time. We use that for blast resistance, okay? And that blast resistance calculation can be used in earthquake zones where we can use it to determine what we call burst. So like in California or even in St. Louis, when they do a pier in the ground, they add fibers to that concrete to help increase the burst condition of the concrete. A little bit of history there. So the cellulose fiber, like I said earlier, it's been around in our neck of the world since probably somewhere around 1965. And where it got started was basically making water pipe. They were making a cementitious water pipe, and they were using cellulose as the fiber and the aggregate. It was the aggregate in there. And this is what Hardie started doing here in the United States. Then they started making Hardie board siding. They started making tiles, underlayment, and stuff like that. What's interesting is that on the tile, let's say, there's a high impact resistance with that fiber in there, okay? They use some different types of natural fiber now, but in some of their products, they're using the same fiber that the Ultra Fiber 500 uses. Comes out of the same plant and everything. So it's been around for a long time. And Procter & Gamble, who was one of the manufacturers of this pulp back in the late 90s, said, hey, we could use this in concrete. And they spun off a company called Buckeye Technologies. It was a planned spin-off because they wanted to just be the makers of diapers, not the makers of pulp. They sold their pulp plants. But they started working on this to sell in concrete ready-mix. So really the first time we've seen cellulose in ready-mix concrete has been here in the United States, and it was done right in Memphis, Tennessee. So they kind of give you an idea. The big difference here is this, is that if you look at fibers, these microfibers, in 1 pound package, in polypropylene, there's about 46 million individual fibers. With the cellulose, you get 770 million. There's a lot of fiber in there, okay? So one of the things we learned years ago about fibers in concrete, the more is better, okay? So you want a whole bunch of fiber in your concrete. The more is better. So the shorter they are, you get higher fiber count, which you're getting with this right here. And that actually helps, it becomes part of the matrix. Becomes part of that cement matrix. So actually it plays out very well in concrete having that high of a fiber count. The other thing is interesting is the cellulose fiber, the cement grows into the fiber. Whereas with polypropylene or with steel fibers and everything else, it's slick and it can't grab onto it. So you got to encroach it, okay? Now the steel fibers have like undulations and things in them to grab onto, but the polypropylene, the nylons, the carbons, they're all smooth. So there you really have to count on loss of ability for it to function because you're going to get some slippage. Whereas the cellulose fibers, the cement actually grows into it, which is kind of a unique thing. Another thing you get with that is that you also allow it to take on color because it's absorbing into the fiber, something that Salomon wanted to have. So the preferred concrete, I'm just going to go ahead and flip all these up real quick instead of them being like this. But basically what ends up happening with this is that these cellulose fibers don't need any type of surfactant or anything in their format, and they're little chiclets. They dice them that way. But they break up in the concrete. It's a mechanical and moisture combination. They break up in the concrete and you don't get that balling. So that's really critical, especially in decorative concrete. So all you guys in decorative, you want to have that. And also because they're not causing a lot of tension at the surface, when you go to use stamps and skins, you don't get that. So they release very easily and you get a really clean profile of what that stamp is, which is kind of a neat type thing. And also that benefits when you're trying to steel trowel concrete. It's kind of like butter on the surface. It has a higher tensile strength than what the polypropylene does. Does that really matter? Well, yeah, because basically you're adding something in there. You're getting some value. Even though you can't see them very well, you're getting an incredible amount of value from that. Bonds well with the cement paste because it works in there, and it provides an internal curing mechanism. A number of the universities, including Purdue University, have done extensive studies on cellulose. And what happens is that it absorbs a little bit of that moisture, and as the cement hydrates, it actually pulls it out of there, like it does some of the aggregates. So you're getting internal curing. It's not a lot, but in the precast industry, it's huge. Okay? Think about precast elements. They're a lot of times a lot thinner. When you start talking slabs, like slab on grain stuff, it's not as critical, but it is with the thinner section people. I'm going to do this whole thing here again. Put these all up here. Oops. Okay, so is it an alternate to welded wire fabric? I love this question. I asked the question, is welded wire fabric a substitute for fibers? Because let's go back to what I talked about what welded wire fabric can do. What does welded wire fabric do in concrete? Doesn't do anything until it cracks, right? And it holds it together, supposedly, if it's put in the right place. Well, fibers can do that, but we can also have additional freestyle resistance, impact and abrasion resistance is increased. We've got better finishability. We don't have to walk on it. It's a safety issue. You're not going to get poked in the back of your head with the wire coming up and hitting you. There's a lot of things that the fibers can do, both in performance and in safety, that the wire mesh can't do. So I look at this as being a stupid question to start with because it's basically accomplishing more than what the wire mesh can do. It's reinforcing in the mixer. Got a ready mix producer in St. Louis. He calls it iron worker in the truck, right? Steve? Or Steve? He calls it iron worker in a truck. Compliance with ICC, IBC, and ACI. Yes. Okay, what that means is that we're in the building codes. We're approved for use in the buildings and building codes. So if you're in the city of Columbus and you're following the ICC building codes, the ICBO, I'm sorry, building codes, the international building codes there, let's say it was 2016 version, we're in there. And then ICC means our product is certified that meets that criteria. Not all fibers have that, by the way. Reduces placement costs. Basically, you can pump with fibers. You've got basically, you got a very slick material. It also improves that freestyle durability, which is critical, especially above the Mason-Dixon line. Some of the cracking that we have here, we got craze cracking here, rapid drying on the surface, might throw some cement on there, and you work it in, and you get this craze cracking, okay? You got some, over here is your plastic shrinkage cracks that we talked about, and temperature. Temperature is an interesting thing because it's actually meaning that there's a difference in temperatures of the concrete, okay? Concrete expands and contracts as temperature increases and decreases, okay? So if you have the fiber in there, you'll be able to have resistance to that. You cannot get that with wire mesh and rebar. Wire mesh and rebar can't address this whatsoever either. And this is a surface situation. So if you've got fiber in the surface, This will help you be able to avoid having this type of crazing. And I've seen this especially in Chicago, where they go up there, and they've done this for years. They'll take that cement and they'll just throw it out there on that concrete and start rubbing it in, and they're actually causing that concrete to set faster on the surface, and it's still plastic below. And then the next day they walk in there and it looks like they got an alligator on the floor. So the fibers tend to allow this to not happen because the concrete actually works faster. It works easier, and they don't have to throw the cement out there. So they're not adding an element that would cause this craze cracking to happen. The other thing is that there's been a lot of question, do our fibers match up with macro fibers? Okay, so the truth of the matter is, when the macro fibers came out was around 2000. They were attacking the steel fiber industry. They wanted to prove that you could use a macro synthetic fiber, plastic fiber for the most part, and replace steel fiber, which was getting the lion's share of the floors, especially warehouse floors. They did all their testing at 6 pounds to 10 pounds, dosage per cubic yard, 6 to 10. And they went out there with this. It took them a little bit of traction to get to a point where people started accepting it, and then 2008 hit. We all know what happened in 2008. Work went sideways. Well, these guys with these macro fibers couldn't sell them anymore. They didn't have enough jobs out there. So they said, oh, you could use this now at 5 pounds. You could use it at 4 pounds. You could use it at 3 pounds. They have no documentation to prove that. The only thing they can do is run average residual strength tests. But that, again, even at 3, 4, 5 pounds, they're getting no plastic shrinkage reduction. But they're telling you that they are addressing everything. Just recently, ACI and ICC have established some testing protocol that they're going to have to meet. So now there's going to be some information out there. But if we want to look at this from a realistic standpoint, why don't we go ahead and test? And we did this at the University of Nevada, Reno. And we took the 4 leading brands of macro fibers, at the time, Grace, Forta, BASF, and Euclid. Would have been at 4 pounds per cubic yard, okay? Each one of them, we made these elongated slabs. The university did this. And then they did 4 pounds of the ultra fiber. And after 1 year, they went out and studied the cracks. And guess what? The post-hardened crack numbers, number of cracks and the total width of cracks, okay, is how they studied this, were the same. No one had an advantage. So the ultra fiber actually performed as good as the macro fibers in all of the 4 other cases. Kind of interesting, isn't it? Now, when it gets to 5 pounds, that's when they really kind of start kicking out. Well, 5, 6, 7 pounds of the macro fibers, there's some value there. There's no, but the microfibers, the Ultra Fiber 500 was tested, and we proved this. And there's some of the data. I'm not going to get into all that, but this was all generated by the university. And that's usually where we get most of the valid studies and everything is through universities. This has been repeated in several cases, but these are these elongated slabs that we're talking about. And they would go out, they would literally take chalk, and they would trace all the cracking. And then they go back and measure all that. The other thing that happened too in this study was with the macro fibers at 4 pounds, the ready mix producer had to use a plasticizer. With the 4 pounds of the ultra fiber, he did not have to use the plasticizer. So there was a workability issue with the macro fiber at 4 pounds, which was an added cost. You start adding the plasticizer in there, you're paying a little bit extra. Just a little side bit on the whole thing. Some of the other data that came out of here, some of the things we were able to figure out was that reducing plastic shrinkage, microfibers at 1 pound per cubic yard reduces plastic shrinkage about 40 to 60%. 1.5 pounds is 80%. So in St. Louis, I told you that we're at 0.5% shrinkage. Okay, if I use 1 pound, I'm going to reduce that about 60% with the ultra fiber. Okay, I'm going to reduce that. If I use 1.5 pounds, I'm going to go 80%. Well, I don't know if I need 1.5 pounds in St. Louis. Think about it. But over in Kansas City, where the shrinkage is higher than normal, I need the 1.5 pounds. So in St. Louis, the standard dosage for a microfiber is 1 pound. In Kansas City, it's 1.5 pounds. Going to show the relationship here. So knowing the shrinkage is important. But if you look at macrofibers, even less than 5 pounds, there's nothing there. They have nothing. Over 6 pounds, they get about 75%. Steel fibers actually do about the same. And then the wire mesh and the rebar, they give you no plastic shrinkage reduction benefits at all. Kind of give you some of the different things here. And by the way, freeze-thaw durability, wire mesh and rebar do not attack that. There are people ask that question, why would it help the concrete resist freeze-thaw, the activity of freezing and thawing, all it's going to do is hold the concrete together if it cracks. so it doesn't have any benefit there for freeze-thaw durability. Another thing is that with the ultra fiber, you get a real clean surface. With polypropylene fibers, which is our nylon fibers, you will see some of them on the surface. It just depends on what type of fibers, what brand it is in the microfiber family. Here's a good one here is that this was up in Canada. One of our guys, our salesman up there, Mark Ryan, took these pictures. They were trying to determine up in Calgary which fiber to use in their sidewalks, for the city sidewalks. Well, they placed this. This was ultra fiber, and this was a macro fiber. And what they did is they asked people as they walked by, what do you think? And everybody said, well, why are the fibers showing over here? Now I told them what to do. They went with the specs now with the ultra fiber. You see that. I went to what was the name of that airport? Harrisburg, Pennsylvania. They got a parking garage there, and they use macro fibers in the inside on the first floor, and it just looks like a Gia monster. It's just unbelievable, and they don't know what to do with it. But that's the way it was spec'd. It was spec'd with 6 pounds of macro fiber, and they're sticking all over the place. And it was really funny because I went through that. They were doing an inspection that day. They weren't real happy with the results there. Another thing is finishing concrete with a steel trowel. I would say most of the microfibers finish fairly well with steel trowel. They really do, even pound and a half. The ultra fiber does excellent because it's like it's real creamy, and you see no fiber on the surface. Really helps that compaction of that steel, using that steel trowel. Again, you guys are here for the decorative fair, and the reason why Salomon purchased this ultra fiber was because it's the only fiber that takes on color. It absorbs it. And so whether you're putting integral color or if you're doing something on the surface such as a stain, you will not see the fiber in the concrete. Okay? The other thing is you get that protection, a plastic shrinkage protection. You're a little more comfortable that your joints will actually activate and not have cracks in between your joints. A lot of benefit with the use of the ultra fiber in this case. In pool areas where you have a lot of moisture and everything else, fibers work very well. People ask all the time, well, will these fibers deteriorate? No. They do not deteriorate. And there's an actual test for this that we have to go through, and it's basically it's a study where if these fibers were to get wet and not be able to hold their strength, they would fall apart. They would rot. They've run these tests for years. They run the tests for Hardy as well. So these fibers, these cellulose fibers, without any real special treatment, can handle this type of thing and not rot out in the concrete. They are there forever. Some of the other work that's been done with them, a lot of polished concrete. Polishers like it because when you do with your plastic fibers, they stick up in the top of that concrete, even though you don't see them. When the steel trowel, when the polishing blades go across there, all those pads, they'll actually ball that polypropylene up and make little lines in the concrete. You get down there and you can see them. Well, with the cellulose fiber, they actually kind of chop off and disintegrate. So you get no problem with the finishability the technique of the finish on the polishing procedures. One of the things that guys have told me, and I'm not a professional polisher, but I've been told you can do 1 or 2 less steps in your polishing. So if you have a 7-step, you can do it in 5 or 6 steps because it polishes easier. Like I said, I cannot validate that. I'm not a polisher. Done a lot of parking lots with the ultra fiber. You can see nice joint patterns and everything. I was down in Lubbock this summer, and I'm going to tell you that down there they have a problem. The different fiber people are saying some different things. The engineers started specifying the use of a macro fiber and everything, and every parking lot looks like a geopet. Okay? It's pretty bad. And I said, what are you guys doing? Well, they were doing everything right. They got the compaction right. They put the rock base down. They got the joint spacing. But they're overkilling on the fibers. I said, you don't need to go there. You can go with a microfiber for what you're doing. And so they're revisiting now in their specs in Lubbock what fibers to use where. And I set up an easy little pattern for them to follow there. And they've been doing it. I've been communicating with lead engineers in the city. And so now they're putting down parking lots that don't look like geopets anymore. Oh, the worst one was a sidewalk. It was at a doctor's office. And I tell you what, you wanted to just bring out a razor blade and start shaving it. It was that bad. It was incredible. And it was pink, and it was supposed to be red concrete, and it was pink concrete. So I don't know what happened with that. I know you guys probably don't do much shotcreting in here. Maybe every once in a while get a pool guy or two. When you use fibers in concrete, it basically reduces the rebound. This product, this ultra fiber, works really well with wet shotcrete methods. Very, very well. They do canals with it and different things. Done a bunch of work out in California with it over the years. So it works very well in a wet shotcrete method. Paving, there was a guy that used to, when Buckeye got started, a guy named Concrete Charlie Lisby down in Oklahoma. He got Oklahoma Department of Transportation to start using it on pavement sections. I'll bet you there's 20 miles down there on the interstate that's got the ultra fiber in it. And needless to say, there's a thing called Port of Catoosa, which is in Tulsa. It's an industrial park. And they used all that ultra fiber in all those roads there with all the tractor trailers. So fibers can be used in a lot of different applications in paving. Pervious concrete. Anybody in here do pervious concrete? For the ready mix guys, the ultra fiber provides the highest permeation of water than any other fiber. This has been studied by various universities, including Middle Tennessee State, and we're really not sure why. And I'm an engineer, I'm supposed to know this stuff. I don't know why we get a higher permeation of water through concrete made with the ultra fiber. Just some information here. Iowa State University did some work with it and everything. We don't get in. It's basically just technical stuff. It shows how well it works versus some of the other the fibers. The thing that really helped us out was that up until ultra fiber, there's been no microfiber, macrofiber, or steel fiber that had a dispensing system. Okay? It's always been in bags or boxes. And you have to get up on the ladder and throw bags in, or if it's steel fibers, you got to put a conveyor out there and start loading it up. So at a convention in Cleveland, Ohio, okay, Buckeye had a booth, and right next to it, Valco Industries, which is in Ohio, that makes chicken feed feeders. They were sitting there and they said, yeah, that media, those little chiclets, they'll go right through our chicken feeder. And that's how we came up with the ultra fiber systems, okay? And there's well over 500 of them out there throughout the country. We got them up in Canada as well. And it's real simple. It's just basically a silo with a screw in the center. It's one out right back out here. You can see it. They got a nice plastic clear tube. You can see but we set them up. We hook them up to the batch control systems. And it's bi-volumetric. They do have to be calibrated on an annual basis. But that's no big deal. It takes 2 people about 15 minutes. But it's a really nice convenience because now no one has to remember to go get the bags or get the right bags. I bet you that's not happened ever before. But it's in the mix design. So it automatically puts the fiber in the mix where it needs to be, up front, in the aggregates, whatever. This happens to be where they're putting it in the aggregates. They put it in the aggregate hopper. Doesn't change your yield or anything because you're not only putting in a pound per yard, so it's not a yield changer. It's very reliable. One of the things about these, I can tell you what, our equipment people love them because we don't get a lot of callbacks. We might get an elbow that gets the screw actually wears out a little bit, but these are very, very user friendly. They've been proven over the years that they've been out there. I think they've been out there since about 2002, so they've been out there for quite a long time. There's many of them that were originally put in there that were actually still in use. The other thing something I did years ago when I was in the fiber technology side of things, I came up with a steel fiber and polypropylene blend. And it doesn't matter what microfiber you use. So I came up with one here for the company using ultra fiber. And the idea is that there's a lot of applications that you want a little bit more steel in the concrete. You want to add that tensile strength. You have some extra loading, like a garbage truck, let's say, or a bus. And the city engineer, he just can't buy off on that microfiber by itself. And he knows the wire mesh is not getting placed right. It's on the bottom of the concrete. He's getting cracks everywhere. So using the steel fiber adds that tensile capacity. And having the microfiber gives you the plastic shrinkage and really good permeability, reduced permeability and increased freeze thaw, abrasion resistance. So putting them together, there's synergy that happens here. So we came up with a product. It's a 16.5 pound bag. There's 15 pounds of steel, 1.5 pounds of the ultra fiber. It's in a water-soluble bag. Bag and all goes in the truck. And now you can look at replacing some of the heavier gauge wire, or in those applications where the engineer says, I'll use fiber, but I need something more than just microfiber. I want something more. And you see this a lot in approach slabs off of a roadway, parking lots, dumpster slabs, alleys, things of that nature. Locations where there's more peace of mind. They want some peace of mind there. This is an alternative to the macrofiber. You'll see a lot of people will be speccing 5 pounds of macrofiber for a similar type application. This is the alternate to that. The difference is there's still a lot of engineers don't like plastic fibers, thinking it because they were taught steel. So they'll buy on the steel fiber before they'll buy onto the macrofiber. Not everybody, but that's still a factor out there. Entrance slabs, city specs. lot of them down in Texas do this. Parking lots that this happens to actually be in Tulsa, Oklahoma. Like I said, it's a pumpable bag, 16.5 pounds. You need to have a little vibration on the surface to seat those steel fibers. There's not a lot of steel fiber, but you want to seat them. You don't want them on the surface. They'll rust if they are on the surface. You can broom or burn finish with that.